In this video, we'll investigate what the shape of a logarithmic function looks like. So let's try to graph y equals the log base 2 of x. Remember that by the definition of logarithms, whenever we see an equation like that, y equals the log base 2 of x, what that really means is that 2 to the y equals x. So remember that when we see logarithmic equations, it's often very useful to translate those back into exponential equations. So if we can think of a pair of numbers, x and y, so that 2 to the y equals x, then that gives us a point that we can plot on this graph. For example, 2 cubed is 8. So that means that we can plot the point 8, 3. Notice that the 8 corresponds to the x, and the 3 corresponds to the y. So we plot the point 8, 3 on our graph, which is going to be right around here somewhere. What would be some other points we could plot? Well, we know that 2 squared is 4, so that gives us the point 4, 2, be right around here. And we also know that 2 to the first power is just 2, so that means we'll plot the point 2, 1. We know that 2 to the 0 is 1, so we plot the point 1, 0. Let's just do a couple more. 2 to the minus 1, remember negative exponents, that means 1 over 2. So that means we're going to plot the point 1/2, negative 1, which is going to be right around here. And let's do one more. Let's do 2 to the minus 2. That's going to be 1 over 2 squared. That's going to be 1/4. So that gives us the point 1/4, negative 2, which is going to be right around here. So this is enough points for us to get the general shape of what this curve looks like. So it's going to look something like this. And as we get our x value closer and closer to 0, our y value is going to get lower and lower and lower. And so what we have here is a vertical asymptote. And then as x gets bigger and bigger and bigger, the y also gets bigger and bigger, but very slowly. Notice that when we go from 4 to 8 in the x value, we go from 4 to 8, our y only goes up by 1. And in fact, we have to take our x all the way up to 16 to get our y up to 4. So 16, 4 is all the way up here. That's because 2 to the 4th is 16. So what we see is this general shape of our logarithmic curve. And really all log curves look like this. So the log base a of x, so y equals the log base a of x, as long as a is bigger than 1, and typically we only think about logarithms where the base is greater than 1, they all have this same general shape. The exact points might be a little bit different, but the general shape of the curve looks like this. So let's think about some properties of these graphs that we can see here. So first of all, the graph of y equals the log base a of x looks like the graph of y equals a to the x, flipped over the diagonal line y equals x. If I were to graph those two functions, it might look a little something like this. Here are my axes. My log curves looks like this. But as we learned earlier, the graph of y equals a to the x looks something like this. And in fact, we can see that these two graphs look like they've been flipped over this diagonal line, y equals x. So we see a symmetry there that connects these two kinds of functions. The domain of our log function is x greater than 0. We can't plug negative values into our logarithmic function. And as x gets closer to 0, my log function gets closer to negative infinity. Finally, we've got a special logarithm function, the log base e. Now remember, e is the special number approximately equal to 2.71828 and so on. So it's a weird number, it's a non-repeating decimal, kind of like pi in that sense. But the log with that as its base, it turns out to have a lot of nice properties, and we call that the natural log function, and we abbreviate that ln. So ln stands for natural log of x. So if you ever see ln, that's just another way of writing the log base e.